Hey guys, Mrs. Stans here. I'll keep this short, but I just wanted to remind you about Lesson 6 and how we solved and graphed our compound inequalities. We did number 1 together. We said when it's separated by the word or, um, it can be in one place or the other. A lot of times or statements have the arrows when we graph it pointing away from each other. Not always though. And we did number 9 together, which was an and statement. And we had said that and has to be the overlap. So if you remember in class, after we solved each piece, we graphed each piece, not on the number line, but we might have done it below it in class. Here it's above it. And we had said that the solution is the intersection of these two. So if I could squeeze these two lines together, you would see that they would overlap starting right where my mouse is to right where my mouse is. It's an open circle to begin with at 4 and a closed circle at 9, and all the stuff in between is the overlap. So that's what we need to do for homework. Something that we didn't stress enough in class is when we don't see the word and or, like number 3. So number 3 is graphed, but you really can't graph it without first solving it. So what I want to show you is that this is an and statement. What they did is they already overlapped it. Here is the first inequality, and this is the second inequality. So it's already been overlapped. I can rewrite this as an and statement. I can write 2 is less than 2x and 2x is less than 6. So I took what I boxed in at first, made it my first inequality, took the second box as my second inequality. So if I solve this, I'll divide both sides by 2. 1 has to be less than x. And if I solve this other inequality, I divide both sides by 2. So x has to be less than 3. So 1 is less than x, and x is less than 3. So that really is represented here on the graph, that x has to be bigger than 1, so the stuff shaded is bigger than 1, and x has to be smaller than 3, so the stuff shaded is 3. It's kind of like I could take these two inequalities and squeeze them back together the way that the problem started and write it as 1 is less than x, which is less than 3. So looking at it this way, you can see that x definitely is between 1 and 3. It doesn't equal 1, that's why I have an open circle. It doesn't equal 3, that's why I have an open circle. If I graphed each one of these separately, I would do it not on the number line. So 1 is less than x. I'll do it up here because this is the only place I have room. I'd have to graph this. And if I were to graph that x is less than 3, I would graph that. And then when I squeeze these two together, um, the overlap happens to be what I have in green here. So that's really what we learned how to do. We solve two inequalities separately, and if it's an and statement, it's the overlap. If it's an or statement, remember only one piece has to be true. Both pieces don't. If I were to do number 5, I would rewrite this as negative 3 is less than m minus 5, and m minus 5 is less than negative 1, and then solve each of these. So why don't you go ahead and solve it? Remember, I can squeeze these two inequalities together to be one compound inequality that says, I'm going to write it in the margin here, 2 is less than m, which is less than 4. I kind of like squeezing it together like this. It makes me see the in-betweenness. It makes me see that m is between 2 and 4. So I need an open circle at 2, an open circle at 4, and shade the stuff in between. So I actually don't bother doing two number lines like what we did up here with number 3 and squeezing together. I actually kind of like just doing the in-betweenness if I see it. If I'm having a hard time seeing it, then of course I'll graph them both. So let's do just a few more together. We'll do another or. We'll go to number 2. Don't let it bother you that it's a fraction. Some of you seem to stress out over this. This is k divided by 4. So the opposite of dividing by 4 is multiplying by 4. So k is greater than or equal to 4. Or in this case, we're going to multiply both sides by 3. So k is less than or equal to negative 3. And this is an or statement. So most likely they're going to point away from each other. K is greater than or equal to 4. So close circle, greater than. And k is less than or equal to negative 3. Close circle, k is less than. And they do point away from each other because or statements only have to be one or the other. I guess we'll take a look at number 4 since it looks like I wanted to start it. I can rewrite it as 6 is less than or equal to x plus 6 and x plus 6 is less than or equal to 11. Solve. Don't forget your word and. Since it's an and, I could like overlap these and say that 0 is less than or equal to x, which is less than or equal to 5. So it's in between 0 and 5, close circle at both, so my graph makes sense. How about, I know there are some tricky ones towards the end here. Let's take a look at number 16. I think that might be one of them. So it's an and statement. Remember, with an and statement, when we're graphing, we're looking for an overlap. I'm going to choose to subtract 4a from both sides. And subtract 15. My 7s and symbols are getting mixed up. And then divide both sides by 7. This is negative 1. Negative 1 is greater than a. And we could either add 14a to both sides or add 3a to both sides. I'm going to choose to add 14a. And then I have to subtract 13. So 0 is less than or equal to 11a. Divide by 11, I get that 0 is less than or equal to a. Now this one, I can't like squeeze these two statements together even though it's an and. And the reason why is because like the a's aren't close enough to each other, meaning like on this side the A is to the right, I would want the A to the left over here. Take a look at this graph. Remember I told you this one was a tricky one. We're going to graph each one separately. I'll do it below the number line. I'll do -1 is greater than A. Here's my -1, so it has to be an open circle. But -1 is greater than A, which means A is this way. A is less than it. And then if I were to graph 0 is less than or equal to A, less than or equal to, it's a closed circle, and 0 is less than or equal to A, which means A goes this way. Remember, this is an AND statement. Therefore, I'm looking for an overlap. Is there an overlap? There isn't. Therefore, this inequality, this compound inequality, has no solution. There is no such A that fits in both of these inequalities. And it's because it's an AND statement. If it was an OR statement, we wouldn't care. Let's take a look at number 17, and then I think I'll be done for today. Sorry, technical difficulties. All right, so this is another AND statement. So solve each one independently, and then take a look. So I solved each one independently. Again, I don't feel like this is something I could squeeze together, because it's not like I don't notice the overlap just yet when I look at this. But there is an overlap. Let's graph each one separately. I'm going to fit it below the number line. So P is less than or equal to 2. Here's 2. It's a closed circle. P is less than. Goes that way. And P is less than -3. So here's -3. It's an open circle. And it goes less than. Remember, I'm looking for an overlap. So if I were to squeeze these two number lines together, I don't think I could actually pick it up. So if I did squeeze them together, you could see that the overlap would be here. It would be to the left of this open circle. So I need to plot the open circle, and I need to plot everything that's in the overlap. So my final answer is what's on the number line. So it doesn't look compound. It looks like it's just one inequality. It looks like it's an inequality that says that P is less than -3. But that's the answer to this compound inequality. So I'm not going to do all of the rest. I think this is enough practice. I'm going to post all the other answers for you. I will show them to you right now, actually. Let me see. So these are the answers all worked out. And what you're going to have to do is maybe pause so that you can check your answers, because I'm just going to show them all to you by scrolling. You pause when you need to, and you can ask any questions that you have in class. Number 20 is a neat one. because everything gets shaded over. All right, hope it was helpful. I'll see you on Thursday.